Okay, we're going to try to graph this. Here, x is negative 3, y is 18.5, so I'll put this up here. Negative 2, y is 27, which is higher, we'll put that right there. 0, y is 5, that's about down here. If it's 1, it's negative 13.5, so it's way down here. It's 2 is minus 29, it's way down there. This is 1, this is 2. 3 is minus 35.5, it's even lower. And 4 is minus 27, which is right about there. So the graph looks something like this. So I'd say negative 2 is a maximum. This would be a maximum, relative maximum. And 3 is a relative minimum. Somewhere in between, there should be a point of inflection, where it's, and that would be x equals 1. X equals 1 right here. Well, this isn't done so accurately. X equals 1 would be 13.5 is right about there. So right there, 1 negative 3 is a point of inflection. That's this, right?
So, Professor, when you're doing this, as a rule of thumb, basically the highest valued number on this side and then the lowest valued number would end up being a maximum and a minimum?
That would be the case provided you use proper test points.
Right.
Remember, we solved our critical values are the black values. Minus 2 was a value, 3 was a value, and 1 was a possible point of inflection.
Those are all here.
So the purple are numbers we have to choose. Numbers test between any two numbers we have to choose a test number, and to the left of everything we choose a test, and the right we choose a test. We see this is what's happening because if it's going up and then it starts going down, this would be the maximum. It goes down and then it starts going back up again. It goes down, it goes back up. This would be the minimum. So this is how we see we have a maximum and minimum. It's also possible to look at the derivatives. This is a positive derivative. This would be a negative derivative. If I find my derivatives are decreasing from positive to negative, I have a maximum. Let's see the derivatives increasing or decreasing.
Could you say that about the derivatives again? I'm sorry, I was closing that door there.
If I were to draw a tangent line here, this is a positive slope. This is 0 slope. This is negative slope.
Yep.
So if you're going to have a maximum, derivatives start positive, it goes 0 or negative. The derivatives are decreasing. So let's look at x equals negative 2. Let's look at x equals negative 2. That's right around here. If I am to the left of negative 2, for example, I have like negative 3 here, this will be if I put a negative 3 here,
negative number.
This would be a negative number, this would be a negative number, so I multiply them, I have a positive number. If I am between negative 2 and 3, for example, if I put in 1 here, this is positive and this is negative, so I have a negative number.
So that's the slope, so it's changing.
The slope of the derivative goes from positive to 0 to negative. That means I have a relative maximum. It's another way to look at it. The slope of the derivative is positive, 0, negative. That means I had a relative maximum. Now, if we keep on going, fine, if I get a number bigger than 3, it becomes positive again. So here the slope is negative. The slope of the derivative is negative. Then it's 0. And it's positive. So that means the slope is increasing. Therefore, I happen to have had a relative minimum. Another
negative, 0, and then positive, right?
That means I had a relative minimum. So you can look at it by looking where is this 0, where is this positive, where is it negative? So to the left of negative 2, this is negative is positive.
This is double check. This is double checking your work. Once we have this here, we're basically set.
An alternate way to look at it.
But it's good to double check your work.
Right. Between negative 2 and 3, 1 is positive, 1 is negative, so the slope is negative. And past 3, both are positive again. That shows you first we have a maximum, then a minimum. There's another way to look at it. And finally, we see the point of inflection is right here. With the second derivative of 0, that's somewhere between the two. It changes from concave down to concave up, point of inflection at 1.
All right,
for
that's
this
good,
problem.
yeah.